Lesson 3. The Behavior of Gases. Reading Guide. Key Concepts. Essential Questions. How does the kinetic molecular theory describe the behavior of a gas? How are temperature, pressure, and volume related in Boyle's law? How is Boyle's law different from Charles's law? Vocabulary. Kinetic molecular theory. Pressure. Boyle's law. Charles's law. Inquiry. Survival gear? Why do some pilots wear oxygen masks? Planes fly at high altitudes where the atmosphere has a lower pressure and gas molecules are less concentrated. If the pressure is not adjusted inside the airplane, a pilot must wear an oxygen mask to inhale enough oxygen to keep the body functioning. Understanding gas behavior. Pilots do not worry as much about solids and liquids at high altitudes as they do gases. That is because gases behave differently than solids and liquids. Changes in temperature, pressure, and volume affect the behavior of gases more than they affect solids and liquids. The explanation of particle behavior in solids, liquids, and gases is based on the kinetic molecular theory. The kinetic molecular theory is an explanation of how particles in matter behave. Some basic ideas in this theory are: small particles make up all matter. These particles are in constant, random motion. The particles collide with other particles, other objects, and the walls of their container. When particles collide, no energy is lost. You have read about most of these, but the last two statements are very important in explaining how gases behave. Key concept check. How does the kinetic molecular theory describe the behavior of a gas? What is pressure? Particles in gases move constantly. As a result of this movement, gas particles constantly collide with other particles and their container. When particles collide with their container, pressure results. Pressure is the amount of force applied per unit of area. For example, gas in a cylinder, as shown in Figure 15, might contain trillions of gas particles. These particles exert forces on the cylinder each time they strike it. When a weight is added to the plunger moves down, compressing the gas in the cylinder. With less space to move around, the particles that make up the gas collide with each other more frequently, causing an increase in pressure. The more the particles are compressed, the more often they collide, increasing the pressure. Pressure and volume. Figure 15 also shows the relationship between pressure and volume of gas at a constant temperature. What happens to pressure if the volume of a container changes? Notice that when the volume is greater, the particles have more room to move. This additional space results in fewer collisions within the cylinder, and pressure is less. The gas particles in the middle cylinder have even less volume and more pressure. In the cylinder on the right, the pressure is greater because the volume is less. The particles collide with the container more frequently. Because of the greater number of collisions within the container, pressure is greater. Boyle's Law. You read that the pressure and volume of a gas are related. Robert Boyle, 1627 to 1691, a British scientist, was the first to describe this property of gases. Boyle's law states that pressure of a gas increases if the volume decreases, and pressure of a gas decreases if the volume increases, when temperature is constant. This law can be expressed mathematically, as shown to the left. Keep Boyle's law in action. You have probably felt Boyle's law in action if you have ever traveled in an airplane. While on the ground, the air pressure inside your middle ear and the pressure of the air surrounding you are equal. As the airplane takes off and begins to increase in altitude, the air pressure of the surrounding air decreases. However, The air pressure inside your middle ear does not decrease. The trapped air in your middle ear increases in volume, which can cause pain. These pressure changes also occur when the plane is landing. You can equalize this pressure difference by yawning or chewing gum. Graphing Boyles Law. This relationship is shown in the graph in Figure 16. Pressure is on the x-axis, and volume is on the y-axis. Notice that the line decreases in value from left to right. This shows that as the pressure of a gas increases, the volume of the gas decreases. Temperature and volume. Pressure and volume changes are not the only factors that affect gas behavior. Changing the temperature of a gas also affects its behavior, as shown in Figure 17. The gas in the cylinder on the left has a low temperature. The average kinetic energy of the particles is low, and they move closer together. The volume of the gas is less. When thermal energy is added to the cylinder, the gas particles move faster and spread farther apart. This increases the pressure from gas particles, which push up the plunger. This increases the volume of the container. Charles's Law. Jacques Charles, 1746 to 1823, was a French scientist who described the relationship between temperature and volume of a gas. Charles's law states that the volume of a gas increases with increasing temperature if the pressure is constant. Charles's practical experience with gases was most likely the result of his interest in balloons. Charles and his colleague were the first to pilot and fly a hydrogen-filled balloon in 1783. Key concept check. How is Boyles' law different from Charles's law? Charles's law in action. You have probably seen Charles's law in action if you have ever taken a balloon outside on a cold winter day. Why does a balloon appear slightly deflated when you take it from a warm place to a cold place? When the balloon is in cold air, the temperature of the gas inside the balloon decreases. Recall that a decrease in temperature is a decrease in the average kinetic energy of particles. As a result, the gas particles slow down and begin to get closer together. Fewer particles hit the inside of the balloon. The balloon appears partially deflated. If the balloon is returned to a warm place, the kinetic energy of the particles increases. More particles hit the inside of the balloon and push it out. The volume increases. Reading check. Graphing Charles's law. The relationship described in Charles's law is shown in the graph of several gases in Figure 18. Temperature is on the x-axis and volume is on the y-axis. Notice that the lines are straight and represent increasing values. Each line in the graph is extrapolated to minus 273 degrees Celsius. Extrapolated means the graph is extended beyond the observed data points. This temperature also is referred to as 0K, Kelvin, or absolute zero. This temperature is theoretically the lowest possible temperature of matter. At absolute zero, all particles are at the lowest possible energy state and do not move. The particles contain a minimal amount of thermal energy, potential energy plus kinetic energy. Key concept check. Which factors must be constant in Boyles' law and in Charles's law?